Let's take a look at today's lesson, which is to classify triangles. When I want to name a triangle or classify a triangle, I can take a look at the differences with the sides, or I can look at it by angles. So let's start on this side first, as most people kind of already have an idea of what this side is. So I'm going to go way out of order here and jump to equilateral. Okay, equilateral is exactly as it sounds. You hear the equi in the beginning, which means the same length. The lateral, or this, like lateral is another word, your lats are your sides. So we're looking at the same length sides. Okay, an equilateral triangle is all three sides the same size. Okay, next let's talk about isosceles. Now, most people think isosceles, they think two sides the same, and that's pretty much the definition we'll use. But technically, the definition of an isosceles triangle is at least two sides are congruent. So therefore, an equilateral triangle is technically considered to be isosceles.
Now, technically, again, I'm putting the at least in there, but most of the time in class, our definition of isosceles is just going to be this. We're going to mostly deal with just the two congruent sides. Okay, moving on to a scalene triangle. So a scalene triangle has no congruent sides. Maybe you'd rather say it has three different side lengths. Now, typically, I mark a scalene triangle by not marking it at all. We cannot imply that sides are congruent or segments are congruent, so technically I have to look at that and assume that all three sides are different. If you want to go ahead and mark them with different tick marks, okay, that's absolutely fine as well. But again, typically I don't mark them at all. Okay, jumping to the other side, and again, I'm going to go way out of order here. Let's take a look at what a right triangle says. A right triangle has exactly one of the three angles being a right angle. Okay, it's not possible to have more than one right angle, but it must have a right angle to be named a right triangle. Okay, let's move on to the equiangular triangle. So yes, that's a funny word, equiangular. So the equi part means equal, angular means angles, so we have three equal angles. Okay, later we will find out that each angle is 60 degrees. That's coming up at some point. But notice for the equiangular triangle, I just took the equilateral triangle and I blew it up. Why is that? Okay, that's because any triangle that is equilateral has to be equiangular, and vice versa. Any triangle that is equiangular has to be equilateral. So equal sides, equal angles. They automatically go together. I'm going to go ahead and group them together so that we can see. Equilateral, equiangular, those two triangles are basically the same triangle. Those two words go together every single time. Okay, moving on to an acute triangle. So an acute triangle, again, we're talking about the angles here. And in an acute triangle, it is important that all three angles have to be acute. So again, all three angles have to be smaller than 90 degrees. Okay, above 0, less than 90. Last but not least, let's look at the obtuse triangle. So the obtuse triangle has exactly one angle that's obtuse. So in my picture, it would be this one. This is my obtuse angle. So if we look at the angles side, okay, for an acute triangle, it needs all three to be acute. For the equiangular, all three have to be equal. But for the obtuse and the right, they only need one angle to meet their qualification to be named obtuse or to be named right.